China's third J-36 prototype just took flight, and that is when the Pentagon started paying closer attention. Not because a new aircraft appeared. The first one already did that a year ago. But because 3 prototypes in roughly 12 months signals something very different. Momentum. In high-end military aviation, programs do not accelerate by accident. So the real question is simple. What does this pace mean for the balance of the 6th-generation race? For most of 2024, the working assumption in Washington was steady. China's 6th-generation ambitions were real, but distant. Complex aerospace programs move slowly. Prototypes appear, stall, get revised, and often disappear before they mature. Then December 26, 2024 happened. An aircraft believed to be the J-36 conducted its first publicly observed flight over Chengdu. It was accompanied by a J-20S chase aircraft. The Airframe carried the marking 36 and the serial 36011, which led analysts to tentatively assign the designation J-36. At first glance, it already looked unconventional. A tailless flying wing configuration, a trijet layout, a broad fuselage suggesting far more internal volume than a traditional fighter. Still, first flights do not define programs. Many demonstrators fly once and never scale. But this one did not fade. By March and April 2025, additional test flights confirmed key features. The 3-engine configuration, dorsal diverterless intakes, split ruddervanes, and what appeared to be a side-by-side cockpit layout. Close imagery suggested recessed exhausts and dedicated facilities at Chengdu Aircraft Corporation. In May and June, repeated flights revealed 3 internal weapons bays, including a central bay estimated at roughly 7.6 meters in length. That detail alone shifted the debate. A weapons bay of that size implies range, payload, and mission flexibility beyond conventional fighter design. Then October 2025 brought a second prototype. Visible changes included 2-dimensional thrust vectoring exhausts, revised intake geometry, and landing gear modifications. That is not stagnation. That is iteration. And finally, on December 25, 2025, a third prototype was observed in flight testing. One notable change stood out: the absence of a pitot tube, often associated with maturing flight data systems. 3 Airframes in approximately 12 months. In aerospace development, that is not routine. And this is where the concern begins. Because this story is not about a single stealth jet. It is about timeline compression in a strategic competition that many assumed would unfold gradually. To understand why the third prototype carries more weight than the first, we need to examine what the J-36 appears designed to accomplish, and how that intersects with America's own next-generation air dominance program. That is where the stakes start to rise. The first public flight in December 2024 did more than introduce a new airframe. It set the tone for how this program would unfold. The aircraft did not appear over a remote desert test strip. It flew over Chengdu, in view of observers, accompanied by a J-20S chase aircraft. That matters. When a prototype is shielded, the message is technical. When it is visible, the message is strategic. And the configuration itself immediately broke expectations. A tailless flying wing layout suggests an emphasis on stealth and internal volume. That alone aligns with 6th-generation thinking. But the trijet configuration stood out. Modern fighters typically rely on 1 or 2 engines. A third engine introduces complexity, weight, and design trade-offs. So why do it? One plausible explanation is power. 6th-generation concepts increasingly revolve around energy demands, advanced radar arrays, electronic warfare systems, sensor fusion, and potentially directed energy weapons in the future. More engines can mean more electrical generation capacity. Whether that is the case here remains speculative, but the design choice signals a willingness to prioritize capability over convention. Then there is the size. Early imagery and satellite assessments suggested an aircraft significantly larger than current frontline fighters. Estimates placed its length in the low 20-meter range, with a projected maximum takeoff weight far above aircraft like the F-35. That scale implies fuel. Fuel implies range. Range implies strategic intent. And this is where tension begins to build. Because geography defines air power in the Indo-Pacific. Distances between bases are vast. A platform optimized for long endurance and large internal payload capacity directly addresses that constraint. At the time of the first flight, analysts debated whether this was a technology demonstrator or the foundation of an operational system. Many leaned toward caution. Early flights are often exploratory. But the airframe did not look fragile or improvised. It looked structured, integrated, deliberate. And when an aircraft appears this mature on its first public outing, the natural question follows. How long has this been in development behind closed doors? That question did not yet trigger alarm, but it planted doubt about the timeline assumptions that had guided the broadest sixth-generation debate. If the first flight raised eyebrows, the flights that followed changed the tone entirely. By early spring 2025, additional test flights began confirming structural features that were harder to dismiss as experimental. The Trijet layout was clearly intentional. The dorsal diverterless supersonic intakes were refined. The split rudder vanes suggested careful control surface integration within a stealth-focused design. But two details stood out more than anything else. First, the cockpit. Close imagery indicated a side-by-side seating arrangement rather than the traditional tandem layout seen in most modern fighters. That choice is rare in frontline combat aircraft. It suggests workload management. It suggests mission coordination. It suggests the aircraft may not be designed purely for air-to-air engagements. Second, the weapons bays. Repeated test flights revealed 3 internal bays, including a central bay estimated at roughly 7.6 meters in length. That dimension is significant. A bay of that size could accommodate very long-range air-to-air missiles, large anti-ship weapons, or future systems not yet publicly disclosed. This is where the conversation shifted from curiosity to strategic interpretation. A large, stealthy, long-range platform with substantial internal payload capacity and 2 crew members begins to resemble something beyond a conventional fighter. It starts to look like a hybrid platform, part interceptor, part strike aircraft, potentially even a forward command node. That possibility introduces a deeper layer of concern. Because the United States is building its next-generation air dominance concept around a distributed model, a manned aircraft supported by collaborative combat drones. The emphasis is on networking, data fusion, and dispersion. The J-36, at least from what is visible, appears to consolidate capability into a single large platform. That does not make it superior, but it represents a different doctrinal bet. And when a nation visibly refines that bet through multiple flight tests in rapid succession, the assumption that it is still years away from operational maturity begins to weaken. At this stage, skepticism remained. Prototypes often evolve. Some never transition beyond testing. But by mid-2025, the pattern was clear. The program was not pausing. It was iterating. By April 2025, another development added a new layer of complexity. Reports began circulating that a flight control system related to carrier operations was under development in connection with the aircraft. If accurate, this would imply that the platform was being evaluated not only for land-based operations, but potentially for naval integration as well. That possibility changes the scale of the story. Carrier-capable aircraft require structural reinforcement, specialized control software, and operational adjustments that are not minor modifications. If engineers were even exploring that path, it suggests long-term planning rather than a narrow experimental effort. And it reinforces a broader pattern. This aircraft did not appear to be a one-dimensional air superiority platform. Its configuration, internal volume, and potential two-crew layout already hinted at multi-role ambitions. Naval compatibility would extend that ambition across domains. At this point, the discussion was no longer about whether China could field a sixth-generation aircraft at some point in the future. It became about how many mission profiles the J-36 might eventually support. Air dominance, long-range interception, maritime strike, command and control coordination. Each additional possibility increases strategic weight. Still, prototypes can stall. Programs can hit technical ceilings. Development can slow under engineering pressure. That is what many observers expected. Instead, October 2025 delivered something that altered the trajectory again. A second prototype entered testing. And this is where escalation becomes harder to ignore. When the second prototype appeared in October 2025, it did more than confirm the program was alive. It confirmed evolution. Visible changes included two-dimensional thrust vectoring exhausts, revised intake geometry, and modifications to the landing gear configuration. These were not cosmetic adjustments. They suggested aerodynamic refinement, performance tuning, and internal restructuring. In aerospace development, a second prototype often reflects lessons learned from the first. Data is gathered, weaknesses identified, trade-offs are adjusted. The appearance of a modified Airframe within the same year indicates that flight testing was producing actionable results. This matters for one reason above all others: speed. Major combat aircraft programs typically stretch across long development cycles. Years pass between demonstrator phases. Engineering challenges delay progress. Budget debates slow procurement. Hey, the visible timeline was compressed. First flight in late 2024. Second refined prototype by late 2025. And testing appeared continuous rather than sporadic. That continuity changes perception. Because even if performance specifications remain unknown, the rhythm of development reveals industrial capacity and political priority. It suggests sustained funding, coordinated design teams, and institutional backing. Then November introduced another data point. Satellite imagery indicated the presence of the J-36 at a high-security aerospace testing site near Lopno. That is not a public showcase environment. It is a controlled, advanced testing location associated with sensitive programs. And when a prototype transitions into that phase of testing, the implication is clear. The program is moving beyond visibility and into validation. By this stage, skepticism about whether the aircraft was real had faded. The question was no longer whether China could build it. The question was how quickly it intended to field it. And then, in late December 2025, a third prototype entered the air. That is when the timeline became impossible to ignore. On December 25, 2025, a third J-36 prototype was observed in flight testing. At first glance, it looked similar to the earlier Airframes. But one detail stood out to analysts: the apparent removal of the pitot tube. That small change carries technical weight. Pitot tubes are often retained during early testing phases to gather precise aerodynamic data. Their removal can signal growing confidence in modeling, simulation, and onboard systems. In other words, refinement. 3 A-frames in roughly 12 months is not symbolic. It suggests parallel testing cycles. It suggests multiple development tracks moving at once. And in high-end aerospace programs, that usually reflects one thing above all else: commitment at scale. This is the point where institutional reaction becomes more relevant than the aircraft itself. Publicly, U.S. officials have acknowledged the development of the J-36 while maintaining that it does not alter the broader review process for America's own next-generation air dominance program. That response is measured. It signals continuity rather than alarm. But continuity can mean two different things. It can mean confidence in a superior long-term strategy, or it can mean that the timeline assumptions guiding that strategy have not yet fully adjusted to visible acceleration on the other side. And this is the documentary inflection point. The J-36 is not operational. It has not proven combat capability. It has not demonstrated superiority. But 3 prototypes, visible iteration, and transition into advanced testing environments eliminate the idea that this is a distant ambition. It is a program with momentum. And momentum in defense development compresses decision space. Because if China reaches limited operational capability earlier than anticipated, even in small numbers, it shifts planning calculations across the Indo-Pacific. It affects basing assumptions. It affects tanker vulnerability debates. It affects how distributed air operations are modeled. That is why the third prototype matters more than the first. The first proved existence. The third suggests trajectory. And that brings us directly to the strategic comparison that now defines the debate. How does this visible acceleration intersect with America's next-generation air dominance concept, a program built around a very different philosophy? That contrast is where the stakes rise from technical to strategic. To understand why the third prototype raised eyebrows, you have to look at the competition. The United States is not standing still. The Next Generation Air Dominance Program, or NGAD, is designed to replace the F-22 and anchor a new model of air warfare. A full-scale demonstrator reportedly flew years ago. The program is real, funded, and deeply integrated into long-term planning. But NGAD follows a different philosophy. Rather than concentrating capability into one large platform, the U.S. concept revolves around a family of systems. A crewed aircraft acts as the central node, supported by collaborative combat aircraft, autonomous drones designed to extend sensors, carry weapons, and absorb risk. The emphasis is distribution, networking, data fusion. In theory, that approach creates resilience. Losing one drone does not collapse the mission. Decision-making is shared across systems. Firepower can be dispersed across multiple platforms. It is a sophisticated model, but it is also complex. It depends on secure data links. It depends on reliable autonomy. It depends on integration across software, hardware, and command structures. The advantage is intelligence and flexibility. The vulnerability is coordination under pressure. Now place that next to what the J-36 appears to represent. a large, long-range, heavily integrated aircraft with substantial internal payload capacity and potential mission management capability on board. Whether it ultimately supports drones of its own or operates independently remains unclear. But from visible evidence, the design consolidates power into a single airframe rather than dispersing it across a network. Two different bets. One favors distributed intelligence and orchestration. The other appears to favor scale, endurance, and concentrated capability. Neither approach is inherently superior. Each carries trade-offs, but here is where escalation sharpens. The NGAD program is structured around a longer procurement horizon, with operational deployment expected in the 2030s. It is also expected to be expensive. Early Air Force estimates suggest the crewed NGAD platform could cost 2 to 3 times more than an F-35, potentially placing it in the $200 to $300 million range per aircraft. Air Force leadership has acknowledged affordability concerns and reviewed force structure accordingly. China does not publish cost figures for the J-36. But visible iteration and 3 prototypes in a year suggest industrial throughput is not stalled by price friction. That contrast introduces a second pressure point. It is not just about who builds first. It is about who can scale sustainably. The third J-36 prototype does not prove superiority. It proves momentum. 3 airframes in roughly a year signals parallel testing, sustained funding, and political priority. In aerospace development, that usually marks a shift from demonstration to serious refinement. And that is the real pressure point. Air power is not just about performance. It is about timing. If China reaches even limited operational capability earlier than expected, planning assumptions across the Indo-Pacific change. The J-36 appears optimized for range and internal payload. That directly addresses the region's defining constraint, distance. Even a small operational fleet would introduce a new variable into basing, tanker vulnerability, and deterrence calculations. This is not about panic. It is about recalculation. There is no public sign that the Pentagon believes it has fallen behind. There is also no ignoring visible acceleration. The United States is pursuing a distributed NGAD ecosystem built around networking and autonomous support aircraft. It is a complex but potentially resilient approach. China appears to be advancing a large, long-range platform that concentrates capability into a single airframe. Two different strategies. One common reality: the timeline is tightening. The third prototype did not shift the balance of power overnight, but it eliminated the assumption that this competition is distant. China's third J-36 did not create a crisis. It created urgency. 3 prototypes in 1 year forces a simple question: who reaches credible operational capability first?